How's it going, my math party people? I'm Coach Anderson, and you're about to watch an ASVAB Arithmetic Reasoning Practice Test Review. So in this video that you're about to see, we're going to go over practice test problems, and we're going to review each one step by step. And don't forget, because if you're in the program, I'm also going to tell you the exact unit that each question is from. That way, you can log into the website, hop into the dashboard, and start learning right away. That way, you're always improving step by step and avoiding that test anxiety that we know can get the best of us sometimes. So, without further ado, let's go ahead and get started. And just as a quick favor, if you like the way that we do things, just remember to like the video, subscribe to the channel, and leave a comment. For sure, leave a comment. That way we know that you support us. So, let's go ahead and get started, and let's ace the ASVAB. So let's go ahead and check this one out here. First things first, no matter what problem we're doing, remember my party people, check out, hey, what's the question asking me to figure out? Keep things simple, because when you start reading the information, obviously, it might confuse you or it might make you assume certain things. So first things first, right here. At this rate, how long will it take Mary to earn $833.75? Okay, cool. If I look at the answer choices, I see that it says hours on all of these. Okay, so everyone, if you're here with me, is it fair to say that what we're looking for, what we want, is the number of hours, blank hours, that will give us $833.75? To keep things simple, is that what we're looking for? The number of hours to get us to $833.75? Absolutely, right? Absolutely. So here's where we can identify what topic this is pretty quickly, almost instantaneously. When we go to step 2 here and look at what we have, when we write down our information, notice how in the question, we're looking for the number of hours that are related to a certain amount of money. Over here, in the information given to us, look at how money and hours are, again, related. Anytime you see that, where you see that the same things are being compared in two separate sentences, that's a proportion, full stop. So let me go ahead and write that down for you. This is Unit 2 of your Arithmetic Reasoning course, and this is proportions. This is proportions, okay? So write that down for yourself. And hopefully you were able to identify that, but if not, no worries. Let's go ahead and understand how we can identify that. Again, when the same things are being compared, that's when we know it's a proportion word problem. And everybody, if you're here live with me in the chat box, how do we treat proportions? What's the main idea that we operate under? Right on, Indy. Lewis, thank you. Compare the same things in the same way. Absolutely. So again, do yourself a favor, write this down. Compare the same things in the same way. Right here, nice and easy. So as long as we respect this main idea, we're going to be fine, my party people. As long as you respect this idea, we're good. And I'm going to show you how this applies. And again, if you want to learn more about this, Unit 2 is what you want to write down in the Arithmetic Reasoning course that we have. Get in there and have a good time. So when I write down the information, I see that, hey, we're going from hours compared to money. So I'm going to start with the hours. 4 hours leads to $115. Nice and easy. So again, compare the same things in the same way. That's really what we're going for here. So with that said, let's go ahead and understand how the proportion is going to be set up. Again, it's going to sound like I'm a broken record, but compare the same things in the same way. If we take a look at this first one here, my party people, we see that we are going for blank hours. We don't know how many hours. So is it okay with you guys if I use the letter H for H hours? Cool. So we have H hours. That'll lead us to $833.75. So that's what I'll write here. H for hours. And in the denominator, I'll go ahead and write $833.75. Next up, again, what we're going to do is compare the same things in the same way. So at the top over here, I had time. And at the bottom, I had money. So that's what I'll do. We have 4 hours here, so I'll put 4 up top for time and then $115 for the money. Yes or no, does that make sense to you? Even if you're here brand new, not having had practice with this at all, does it make sense that the main idea here, to get a proper setup, just compare the same things in the same way? So we wouldn't multiply money with money and hours with hours, is we would line up money with money and hours with hours. Yeah, we would line it up in the same way. So cool. So hopefully we're set up there. And again, if that didn't make too much sense, again, we have all of this remedial practice and lessons and everything you need to really get confident and engage with this unit 2. But after we set up our proportions, everybody, here's what we need to really look at. Once we have the setup, it's, hey, how can we solve this as quickly as possible? So give me some ideas, guys. What's the main way that we typically solve proportions? What's that one method? The main one that everybody's taught? What's the main way that we're taught? Yeah, typically it's, hey, let's cross multiply and divide, right? You know, if we went to school, typically that's what we're going to hear. Cross multiply and then divide. Now, there are times where there's going to be more that we can do. Give me one moment, guys. 1 second here. Obviously, need to take a second to address that. All right, perfect. All right, so go ahead and drown out the chat. So with that, go ahead and drown that out and we will be good. Yep, I know. So with that, boom. So the way that we actually solve the proportion, it really does matter, guys, because remember on the ASVAB, what we're trying to do is save time. We don't want to take all the time in the world to do one problem. So with that said, here's what we can do. Cross multiplying will get us to an answer eventually. Another way to do it is by, again, comparing the same things in the same way. So if we take a look here, everybody, I can compare the same way and be fine. So watch this, everybody. What's a good estimate that you might think of for going from 115 to 833? What number would you say is a good guess? It doesn't have to be super accurate, but what's something that would get you in the ballpark? Do you think times 2, times 3? What do you think? Times 6, times 5, times 7, times 4. And even if you're looking at it straight up from just the biggest number you have here. So like, let's say from, instead of thinking of it as 115, let's just take a guess. Let's think of that as 100. Here we have 833. Just think of that as 800. Everybody, if we're going from the 100s to the 800s, what's the number that might pop into your head for multiplication purposes? What number might pop in? If I'm leading you that way, if I'm saying, hey, from the hundreds to 800, from 1 to 8, I think we can say times 8 would be the case. So just hear me out and watch how this might save you time. And the reason I'm even going to talk about this little technique that I'm going to show you is for the simple reason being that when you look at the answers are pretty spread out apart. They're pretty spread out apart. And that's going to give us a nice little advantage because if we're going to start guesstimating, we might be able to save time with a nice little guesstimation method. Here's what I mean. Right over here. Everybody, if I went times 8, would I be higher or lower than 833? What do you think? If I multiplied 115 by 8, do you think I'll be higher or lower? Yeah, a lot of us here are saying higher, and that's absolutely true. Absolutely true. So, with that said, everybody, what's 4 times 8? Again, this is how proportions work. In a nice little twisted way, as long as you're going in the same direction, you can do the same thing. So if I were to allegedly go times 8, just taking a little guesstimation, I'll get to 32 exactly. But what did we say over here at the bottom? We said that would be too high, right? That would be too high. We tried to get somewhat kind of close, but we said times 8 would be too high. So that means that 32 would be too high. Which number is just below 32? Answer choice B. Answer choice B is right below 32, and by a very close margin compared to what else? 66, 41, 16 and a half. So it wouldn't be C or D automatically because those are higher. That would make no sense at all. But if you go to B, A or B, well, A, that's half of 32. Obviously not exactly half, but just about half. We're not that bad at estimating. B, 29, it's just below. Everybody, do you see how guesstimation, even if we don't have the exact number, do you see how estimation can get us to a reasonable solution? Perfect. Perfect. All right, so with that said, let me go ahead and show you the exact way to do it again, though. Let me show you the straightforward way. Again, the answer is B, and we just use a little guesstimation. Let me go ahead and show you with cross multiplication and division how this might take a little longer, but we'll still get to the same correct answer. Let me let these folks in. All right, cool. So let me go ahead and show you here. Right there. All right. Let's go ahead and cross multiply here, and we're going to go ahead and show h multiplied by 115. That'll just be 115h. I'm going to say that casually, like that's not going to haunt me in a couple of seconds. And then over here we have 833.75 times 4. Obviously, I'm not going to try to do that in my head. We're going to want to go ahead and write that out. So let's try that out here. 833.75 times 4. Multiplied by 4 right there. 5 times 4, that's going to give us 20. 7 times 4, that'll give us 28. Carry the 2, that'll be 30. 3 times 4 is 12. Carry the 3 is 15. 3 times 4 is 12. Carry the 1 is 13. 8 times 4 is 32. Carry the 1 is 33. Boom. So we have all that going on. And everybody, once we do that, what do we do with the decimals again? Right, we end up putting it back. Absolutely. We end up putting it back. So with that said, booyah, we're good. We have 1, 2 decimal places back. Again, this is the way that will absolutely work. We just cross multiplied. So we can go ahead here and say 3, 3, 3, 5. And now what we'll do is the second part of that, which is divide. Exactly. That's what we'll do now. We'll go ahead and divide. So with that, right over here, what are we dividing both sides by again, everybody? What are we dividing both sides by? Yep, 115. So we'll go ahead and do that nice and easy. That's going to cancel that out on the left side. And then we're going to have h equals whatever that division is going to be. Now, in your opinion, is this something you're looking forward to? 3,335 divided by 115? Right, absolutely not. But don't worry, remember, this is a valid way to do it. But just remember that on the ASVAB, it does help to know more than one way to do something. It does open up some advantages for you. So even if you didn't know that estimation strategy that I just showed you, don't worry. I'm going to show you the correct answer, how we get it explicitly. And I'm going to double back to that estimation strategy and show you why, again, hey, if you know it, in this particular situation, it was beneficial. So let's do it. So we have 3,335 divided by 115. So let's set that up right over here. Okay, so let's play the guessing game. All right, everybody. So how many times does 115 go into 3? None. 33? None. 333. How many times will 115 fit into 333? Here's where you got to know your division, right? You got to know how to divide on your feet. I'm going to say times 2. Because here's the thing. We can use a little bit of mental math and say, hey, 115 times 2. 100 times 2 is 200. 15 times 2 is 30, so 230. Okay. If we added another 115, that would be 345. Too much. So 2 it is. So I'll go ahead and say, hey, so far we have 2. And I'll go ahead and subtract 230. And that's going to give me 3 left over. Or excuse me, my bad. We're going to have 103 left over. And then we're going to bring that 5 down. But here's the thing, my party people. Again, when it comes to the ASVAB, it's better to take less time than more. And the reason I say that is because, everyone, quick question. Once I finish this division, is it true that I'll have the answer? Once I finish this division, is it true that I'll have the answer? And just take a look at the equation. We were looking for h. We set up our equation, and it looks like we're about to be ready to solve for h. This is going to give us the answer, everybody. This is going to give us the answer right here. Just take a look at the proof. We cross-multiplied and then divided to get whatever h was. So we know that whatever solution is here, whatever we get as the quotient, that's going to be the answer. We don't need to take time guessing how many times 115 goes into 1035 when, if you take a look at the answer choices, what's the only answer that starts with a 2? B. So remember, everybody, the ASVAB is just as much about test-taking strategy as it is about knowing how to do the actual problem. Because if you can kind of leverage the fact that, hey, these answer choices all start with different numbers, I don't have to torture myself and finish a calculation like this, like how most people would do and say, hey, I gotta guess 115 times 8. Let me see if that'll work. 5 times 8, 0. Carry the 4, and then you start, messing around and hoping for the best. But if you look at the answer choices, it gives it to you. It's probably 9. Let's try out 9. Let's bring it over here. Let's do 115 times 9. That's 45. 1 times 9 is 9. Carry the 4 is going to go ahead and be, 13. Great. Then 1 times 9 is 9, and then carry the 1 is 10. 1035, 1035, and there we go. And we can take an effective guess in that way. So really quick, everybody, does using the answer choices in either way that I did, whether it was the first method or at the end of this really long division, does using the answer choices when it fits make sense to you? Okay. And remember, they're not going to put, some questions, the answers might be spread out apart. Some other questions, those answers are really close together, like 8, 9, 10, and 11. So there's going to be different situations where that might apply, where that might not apply. What I'm saying is pay attention. Because if they give you an advantage like that, take advantage of it. Take advantage of it. Now, there are plenty other ways to solve this problem, but when you look at the other things that I've taught you if you're in my program, like going ahead and finding out what the relationship from 4 to 115 is, or 115 to 833 is, might not be the best case in that method because there's actually not a solid number that'll work. So that's why I did show first the guessing method, but then I went the traditional route with the cross multiplication and division. So where are we at right now with this problem? Do we understand that 1, it's a proportion, and 2, do we also understand how to solve it once we set it up? How are we feeling? Hey, Kyle, thanks for sharing that. So if you did times 7, if you did 115 times 7, what you would have gotten, Kyle, would not have been 833.75. You would have gotten something just below 833.75. I believe it would have been, it might have been 825, what you would have gotten. But you would have been right below that 833. So you could have made the guess and said, oh, wait, since I'm right below it, it has to be just above 28. And that would have been 29. Yeah, iPhone, great question. So again, the reason that we know that this is for sure a proportion problem is because you're comparing the same things. In the first sentence, notice that we're comparing, hey, this many hours equals this much money. And then in the question itself, in the red highlight, it says, hey, for this many hours, I don't know how many hours, get this much money. So in both sentences, hours and money were being compared, but in the question sentence, you're just being told to find one of those pieces, the hours. So again, when you're connecting the same pieces of information twice, proportion. Or they can just say the ratio of this to this. That'll be a proportion problem as well. So Jaden, long story short, for the 29 from the 32 is just saying, hey, when we multiplied by 8, we got an overestimation. So we knew the answer had to be lower than that. Because again, when we multiplied by 8, we went over the correct number. So we had to go down, and we saw that 29 was right there. That's all it is. 2 minutes. First things first, let's go ahead and, hey, read the question. What are we looking for here? And it says clearly, what was Barbara's average reading speed in pages per hour? Okay, sounds good. So here's how we can tell that we're dealing with a y equals mx plus b problem. Let me go ahead and just list this out for us here. Everybody write this down. Y equals mx plus b. So, thank you, Ron. I appreciate that. The way that we know that we're dealing with m is per for sure. But let me go ahead and explain each of these little pieces really quick. Everybody, b, let me start from the end over here. B represents what when we're setting up an equation? Let's keep things simple. In English, what does b represent? What does b represent? The beginning amount, the initial amount, right? So let's write that out. That's your beginning amount. Your beginning amount. Okay, cool. Now, next, let's talk about the letter m. And the reason I'm going to be talking about x and y last is because they're actually a pair. They're connected. So let's talk about m real quick. Everybody, m represents the slope. But in English, what does that represent? That's going to be your rate. Exactly. That represents the rate. And the key word that tells you that you're dealing with a rate is what, my party people? What's that key word? Yeah, that word per. That word per is what gives it away. Again, if you're having a little bit of trouble kind of keeping up, reading through these pieces, just make sure that you understand we're dealing with Unit 6, solving equations, word problems. And again, don't look at that B over there. That is horrible. So with that, let me go ahead and talk about X and Y, and let me talk about why they're a pair. Everybody in the chat box, real quick, is it true that when you're dealing with the coordinate grid, X and Y, is it true that X and Y are written as a pair like that? Is it true that they're written as a pair? Yep. Yeah, it's true. I mean, if we go through that lesson in math knowledge or arithmetic reasoning, it's going to be just the same. X and Y are a pair, whether in pure math or in word problems. Basically, X represents typically time, and Y represents the result after that amount of time. So here is the result after X, and I'll put that in quotations there, or mini quotations, X time. So for example, if X represents minutes, then Y would be the result after that many minutes. If X represents hours, then Y would be the result, the page number or the miles or whatever, after that many hours. So X and Y are connected. And seriously, the moment that we get used to talking about this math equation in English, that's as soon as you'll be able to look at more problems and say, okay, cool, that's where this goes, that's where this goes here, this goes there, solve, and I'm done. So one more run through before I show you how to do it with this problem. It's like this. Y equals mx plus b. M is a rate. That's your slope, but it's a rate in English. The word per gives it away. Pages per hour, miles per minute. You know, those units with the word per in the middle, bam, that's a rate. B is always the beginning value. So whatever the problem tells you that we started on, you know, hey, initially we were here. That's your beginning amount. That's what B will always be. The beginning amount, B for beginning. And then again, X and Y are connected. X is typically time. Y is typically the result after that amount of time. So with that knowledge in our heads here, let's show you how stress-free this setup can actually be. Here we go. Everybody here, in 5 hours, Barbara read from page 122 to page 467. What was Barbara's average reading speed in pages per hour? Okay, let's break things down for ourselves. Everyone, what is the question saying that we're looking for? What was Barbara's average reading speed in pages per hour? What are we looking for in the question? What do you think from what I described here? Right, the rate. What gave it away for you again? What gave it away? Yeah, the word per. Right, in pages per hour. Pages per hour. So right there, boom, that gives it away. We are looking for this. So let me highlight that for us. Right over there. Bam. All right, cool. So here, starting from the beginning, in 5 hours, everybody, what do we think 5 hours is? The Y, the X, the B? What does that mean? Right, that's going to be X. That's the amount of time that was taken here. So boom, 5 hours, that's going to be X. Can you tell me what the result was after 5 hours? Who knows what the Y is going to be? Is it the 122 or the 467? Okay, I see a lot of us are saying the same thing, 467. Can you give me a reason why? Why is Y going to be 467? Thank you for explicitly stating that. Thank you. Yeah, why? It's because it's the ending amount. It's the end result. It's what we have as the result, what we have at the end. It's page 467. Yes or no before I continue? Does that make sense to everybody? Again, the X is the amount of time and Y is the result that you get after that amount of time. So here, that's going to be page 467. That's the page number that we get to. That's the end result after 5 hours. So with that said, everybody, what's going to be my value for B? What's going to be the value for B? The 122. Everybody, that's because B stands for the... That's because B stands for what? The beginning. Not begging, Lewis, but beginning. I think we have been confusing Dominic's behavior for ASVAB shirts. But yes, beginning amount. That's it right there. So boom, that's going to be the page 120. That's going to be page 122. So there we have it. Look at how crazy this is. Once you actually learn to speak the language of setting up a linear equation like this, once you set it up, if you know how to solve an equation, you're done. Watch. I know that Y is 467, so I'll write that out in place of the Y. Again, the Y, 467. Next up, we're looking for the M, so I'll just leave M as is. Then we know that X is going to be 5, so I'll put 5 right there. And then we're adding B, which is 122. So if you want to rewrite this, it would be written like this. 5M plus 122. Long story short, my party people, is this solvable? Yep, this is absolutely solvable. Absolutely. What's the first step that I'm going to take, everybody? What's the first thing I do? What's the first thing I'm going to do? Subtract. Subtract what? Where? With who? Subtract 122 where? Both sides. That's the simple answer right there. Subtract 122 from both sides. So that's exactly what I'll do here. And now I have an interesting piece of note here. It's something I want to take note of, and it's this. For those of you that were asking me, hey, coach, could this be a distance, rate, time problem? Could this be it? Absolutely. Watch this. Once I do the subtraction here, I'm going to end up getting, what, 345? Yeah, cool. So I get 345 equals 5M. Everyone, if you're doing a distance, rate, time version of this, this is the setup. Your distance is 345 pages that were read. Your rate is the number of pages per hour, and your time is 5 hours. Remember, 5 times M is the same as M times 5. If you wanted to look at it as a distance, rate, time problem, this is it. That would be it right there. Let me know if you did it as a distance, rate, time problem, and this is what you got. Let me know. But regardless, the way you're going to solve this is going to be by dividing by 5 on both sides. Exactly. So bam, right there. And then we'll go ahead and take 5 into 345, and we're good. So 5 into 34, that's going to be 6. And then 5 into 45 will be 9. Subtract 45 on both sides. That is a clean number there. Boom, 69, and we are good. The answer is 69 pages per hour. Yeah, and again, either way you could have gotten it done, whether you set it up as a y equals mx plus b problem or as a distance rate time. Remember, distance represents the difference from start to end, like how far you went. And here in the terms of pages, that's just the difference of the number of pages. Yeah, hopefully we're feeling good about that one. And I'm really hoping that you're excited for the next one. Cool. Sounds good. How are we doing so far? Anybody here 2 for 2, 1 for 2, 0 for 2? And regardless of what we've got going on, remember, like I said in the beginning of class, it's about, hey, can we take these mistakes, learn from them, and guarantee that maybe next time we're not so prone to making that same mistake. Okay. I like math a little bit more. There we go. Dreams do come true. Look at that. Now I know the importance of knowing what kind of question it is. Exactly. If you can tell, like in the problem here, as I'm reading through it, I'm looking for a rate. So that's exact. So I pointed that out from the very beginning. Then the information that I read, 5 hours, time, 122 to 467, beginning and end. So then I have the option of saying, hey, I could try to set this up as a DRT problem, or I can do y equals mx plus b. They're literally the same thing, just different forms of setup. But once you plug in your numbers, you're good. You solve and you move forward confident, knowing that the pieces that you have fit the topic that you generated from that problem. Yeah, if you didn't know, distance rate time is legitimately the same thing. Distance rate time is the same thing as y equals mx plus b. It's just when you put the y and the b on the same side as y minus b, the end minus the beginning. Yeah, it's really interesting, actually, when you go through it more and more. So with that, let's go ahead and jump right into the next one here. We only have a limited amount of time. We have just about an hour left. Let's keep having fun here. Let me get the timer up, and we'll do another one here. 3, 2, and go. So let's go ahead and give this one a shot, my party people. So what we're looking at here is a question about, well, volume. And it's because it's given away and the shape is given away. So we're going to talk about that in a moment. But no matter what, the first thing we do in any word problem is, hey, what's the question? Read the question first because you want to identify the goal before you get into all the hoo-ha about what formulas and what shapes we're dealing with. So here we go. First things first, read the question. So we'll say right here, what is the height of the second box? Okay, cool. So again, I don't particularly know if I just read that, nothing else. Okay, the height of the second box. So I'll go ahead and write that here. Second box height equals, okay, it says feet there, so I'll just say blank feet. Again, just to get the ball rolling here, just to get something. And we want to be confident that we know what we're looking for, so everybody is cool with you. Is it safe to say that there are apparently 2 boxes, and we want to know how tall the second one is? Can you do a visual just to see how it looks? Absolutely. You guys know I'm the Picasso of math. I don't even need to use the tools on this app to draw straight lines. I just draw straight lines naturally. So let me go ahead and kind of just draw it out for you. Again, I'm not going to use any of the features here because I can draw that good. Just close your eyes. You're good. Boom. There you go. Yeah, perfect drawing, guys. Look at that. See? That's how we do it. So there it is, the most perfectest drawing in the world, and this is a rectangular prism. That's what's highlighted right here. Cool. So that's what a rectangular prism looks like. Basically, it's a box. Pretty much, okay? So here's the key to this question. The moment that you know that you're dealing with a geometry word problem, you got to make sure that you are ready to regurgitate any and all formulas that you need. So, with that said, my party people, let me go ahead and point out the exact unit that this is from. This is going to be from We have like 4 units on geometry here. So this one's going to be unit 11, okay? If you're in the course, arithmetic reasoning, unit 11, volume word problems. And so when I start reading through the information, just follow along. This is how we discover this information. It says 2 boxes, rectangular prisms. That shouldn't be the trigger yet. They gave you the name of a shape, whatever, but you need to know what about the shape you're dealing with. Then it says have the same volume. Right there. That's the key there. We really need to pay attention to that. Everybody, the moment that you're given an explicit math word like that, like volume, the first question I always tell you to ask yourself is, what shape? Because, everybody, when you have a specific math word like volume, and you know the shape, what do you also know? If you know the name, the exact math word, with the shape that it accords to or belongs to, we can then know the formula. And so everybody, what's the formula for a rectangular prism or a box? What's the formula for a box? Kai, thank you. You got it there. Length times width times height. So if you didn't know that, go ahead and write that down for yourself. The volume of this box right over here, again, the one that I drew by hand, no help needed. Volume equals length times width times height. Booyah. Right there. Okay, so do yourself a favor, write that down. Again, this is for rectangular prisms. Okay, so I'm going to write that down here. Rectangular prism. Again, a box with rectangles as the faces. That's pretty much all that is. Damien, I don't know why you're acting surprised, man. You've been crushing it. So with that, boom, there it is. And so when we take a look further at the information, again, we have 2 boxes. But everybody, what's the most important piece of information? Not that we're dealing with volume of rectangular prisms. What's one other word that I should highlight in this sentence? What's one other word that I should highlight? Lambda, right there. Same volume. And Damien, you're correct about that. Sorry about that. But yeah, same volume. That's a very important note that we should take right over here. So the volume of box 1 equals the volume of box 2. And everybody, is it true that the volume of box 1 is going to be the length times the width times the height of box 1? And the volume of box 2 is going to be the length, the width, and the height all multiplied of box 2? Is that true? Cool. Yeah, as long as we know these truths, then we're good. We're absolutely good. Watch this. We're good. Bam. I'm going to find out I'm going to highlight this one I'll do this one in green, and I'll go this one in blue. How about that? To make things simple. So for box 1, we have the length times the width times the height equals, and then in blue over here, again, length times width times height. Just to keep things clear. Now watch this. The first box, that's what it says right here. The first box right above me, it says measures 5 feet in length, 8 feet in width, 6 feet in height. Okay, so I'm going to put those numbers in. 5, 8, and 6. 5 times 8 times 6. Let's see what other information I have here. What else do they give us? Then it says over here, it says, hey, the second box measures 12 feet in length and 10 feet in width. Okay, great. So it looks like we're going to have ourselves 12 times 10. And then that h that we're looking for still right there. Bam. And once we set this up, everyone, does this look very doable to you? Does that look doable to you? Yeah, I would hope so, right? I would hope so. I would hope that this gives us an opportunity to get this down. So there are really 2 main ways. Once you get to this point, the purpose of problems like this is, 1, if you know your formula, your setup's going to be confident and you're going to feel pretty good about this. But other times, like we saw in this, the first problem that we did, sometimes even if it's a quick setup, you might see that the work that you do takes a long time to execute. So remember in that previous two questions where we went over that proportion question and there were decimals involved and a lot of calculation? Let's see if that's the same case here. Here's one way we can go about it. Number one, let's just go ahead and multiply everything straight up here. Everybody, 5 times 8 is what? Hit me. 5 times 8 is what? 40. Then if we do the 40 times 6, what's 40 times 6? Quick. What's that going to be? 240. Okay, great. On the right side, let's go ahead and do the 12 times 10. 12 times 10 is going to be what? 120. And we still have that h attached to it. Sounds good. So from here, it looks like we just need to do one more thing before we're done. And that's going to be dividing both sides by 120. Yep, and we're set. So divide both sides by 120. I'll make sure to catch that question in a moment there, Yahweh. So boom, 120, cancels out, and we have ourselves 240 divided by 120. That's going to be what? Yeah, it's going to be 2. So we have 2 equals h, and since h represented, what was that, the height, that's going to be a height of 2 feet. And there we go. So here's the thing, my party people. Number one, you needed to know that we were dealing with the volume of rectangular prisms. If you can identify that and really instantaneously get that formula out of your head, great. That's a very good position to be in. But number two, what makes this problem slightly unique, slightly harder than a very, very basic volume question is the key phrase, they have the same volume. That's the key here. So knowing that, you need to be able to adjust your approach and say, okay, if the volumes are the same, everybody, what's the math word for the word same? Starts with an E. What's the math word for the word same? Equal. Exactly. So that's how you know that if they say that we have the same volume, you can literally say the volume of that first box equals the volume of the second. You have now stated a mathematical relationship that we can then exploit, set up, and solve nice and easy. Nice and easy. Again, it might take some practice to get used to the setup, might take some practice to get used to solving equations, but that's the benefit of being in this class because I have now told you that, hey, this is the unit that we're working off of, and so it'll be a very good idea to work up to that or specify exactly what you want to work on. Makes life easy. So let me just answer that question from Yahweh earlier because I don't want to overlook that. So if we were looking for the height of the second box, why do we need to add information from the first box if information for the second box is already given? Well, think about it like this, Yahweh. We could set it up like this, only using the stuff from the second box. This is what we have for the second box right here. Let's suppose that this is all we had. Let me just duplicate this over here. Let me just make that a little smaller. And then we would write the word V for volume. The problem, Yahweh, and all of my students here is this. If we didn't use that information from the first box, notice how we have an equation where we don't know H, but we also don't know what V is. You can't solve for H if you don't know what V is. Remember, in an equation, if you have two variables, you can't solve one equation that has two variables. You can't do that. So let me know if that makes sense. The information, knowing that the volumes were the same from boxes 1 and 2, allowed us to find the volume of box 1 and attach that 240 right there and say, yeah, we actually know what that is. Take that out. That's going to be 240. And now we can solve. So if we overlook that one word, the word same, we would have been done for. I don't know if that makes sense there. Cool, sounds good. And so the last thing I want to address is that comment there saying, hey, I actually subtracted 12 minus 10 and I got 2. That's just coincidental. And, obviously, if you did that and you got the right answer, great if it's the actual ASVAB, but you should never be proud of taking a lucky guess on a practice test. Maybe you're a little more lucky on some questions than others. Save that for the ASVAB. On practice tests and when you're doing about your regular studying, you shouldn't want to move on until you actually know how to do it. It's a good practice. So if there was no same, then they would have given you the volume straight up. They would have given you the volume straight up or some other relationship, something like, oh, it's half the volume of the first box or double the volume of the first box or something like that. But they have to give you enough relationships to solve the problem from beginning to end. They have to. No, I wouldn't consider this super complex. I really would not consider this super complex. This would be something that you should be prepared to do after having a formal introduction into that topic. So like once you learn volume formulas, area formulas, perimeter formulas, and basic plugging in and solving, then you add like little quirks, little twists. Hey, these volumes are the same. Or hey, this thing is 5 more than that thing. They start adding relationships to kind of throw you off. So this is a medium question. I wouldn't call this hard by any means. With enough practice, you'll see the same. So hopefully I've answered your questions there. Let's go and get ready for the next one, my party people. So here we go. Let me get this clock up and get my face out of the way. And 3, 2, and 1. Let's keep the party going, man. Let's have fun. So, advanced word problems, but this is called a combined work word problem. I'm going to point out how you know this is it. Combined work. Okay? This is a combined work word problem. Now, if you don't know what a combined work word problem is, it's this. Basically, the giveaway is when you're talking about, hey, if it takes this person this long to work by themselves, this person that long to work by themselves for the same exact thing, how long will it take them working together? Or if they tell you how long it'll take you for them working together, and then one of the people by themselves, find the other person by themselves. Long story short, when you have these 3 pieces of information in play, when you have 2 individuals who they're mentioning doing a certain task by themselves, and then they also mention the time it takes for them to do it together. Whenever you have those pieces of information, 2 individuals and then them working together, the time specifically that they're mentioning, that is a combined work word problem. And here's the setup for it. Here's the equation of the formula that you may not have seen before ever, but this is me going over it with you. The formula is this: 1 over A, plus 1 over B equals 1 over T. So basically, A means person 1, B is person 2, and again, these are all times, and then T is the time it takes them together. Now, does this make sense to anybody here at all? Be honest, be honest. Does it make sense to you? Does this make super duper sense? I'm expecting a bunch of no's. So it may look simple, but I really do want you to be able to explain this to yourself, okay? Everybody, here's why this looks crazy. Here's why this looks like we flipped fractions over and over again. Instead of saying A plus B equals total, let me show you why that actually wouldn't make sense at all. Think about it like this, everybody. Let's go ahead and I'm going to use someone as an example. Dedrick, since you were the last person to type in the chat box, me and you, that's who it'll be. So me and Dedrick are talking, right? So let's say Dedrick and I are running a lawn mowing business. And Dedrick says, hey man, that lawn right there, me by myself, that'll take me 30 minutes. To mow that lawn, me by myself, it'll take me 30 minutes. I say, okay, cool. Hey man, look, me by myself, that'll probably take me 20 minutes. I'm the owner of the company. I've been doing this for 3 times as long as you. Maybe it'll take me a little less time. So for me, that yard by myself, it'll take me 20 minutes. For Dedrick, 30 minutes. Everybody, quick question. If we start talking about me and Dedrick working together, if it takes him 30 minutes and me 20 minutes, how long should it be working together? Is it 50 minutes, right? Is it 50 minutes? Since he takes 30, I take 20 by myself. So there you go. Notice, that would not make any sense at all. Because if it takes me 20 minutes and it takes Dedrick 30 minutes, working together, shouldn't it take us less time, not more? And that's the reason. That's the reason right there. That's why these are flipped. The reciprocals are taken, or they are inverted. Because when you start talking about combining the amount of time it takes to do work, it is not a direct A plus B equals total. It's going to be, hey, using this formula, what this represents is, hey, in 1 hour, this is how much work the first person does. In 1 hour, this is how much work the second person does. And then in 1 hour, this is how much work they do together. So we're talking about the amount of work being done. That's how this formula is set up. Not in terms of the amount of time, but how much work is done. So even if that doesn't make too much sense, all you need to know is this, my party people. When you're dealing with a combined work problem, where you're talking about individual takes this much time, this person takes this much time, how much time together working on the same thing, this is your formula. 1 over A plus 1 over B equals 1 over T, where T is the time that it would take them together. So again, there it is. I do have plenty of videos on this on the website as well, but let's go ahead and show you how simple it can feel after we get past the setup. Because for these problems, honestly, the nastiest part is the setup. Once you get past that, chilling. But either way, this is still a top 1% problem. So here we go, my party people. Here we go. Working together, Timothy and Betty can complete a certain task in 16 minutes. Everybody, if we're looking at our formula, what do you think, where do you think this would belong? Timothy and Betty can complete a certain task in 16 minutes if they're working together. Where would that belong? Right, that's the value for T. So let me just go ahead and show you right away. Right away. Boom, that's the amount of time it takes them working together. 16 would be it right there. The T is 16 because that's the time it takes working together. Okay, cool. Next up, it says, hey, it takes Betty 80 minutes working by herself. And then we're looking for how long it'll take Timothy to work by himself. Okay, cool. So it doesn't matter which one you pick. A could be Timothy or A could be Betty. It doesn't really matter at all. 1 plus 2 is the same as 2 plus 1. It does not matter. That's a good advantage that we have. All we got to do is plug in 1 for something. So here we go. We'll do 1 over A. I'll just keep that as, right there. That's Timothy. And then we'll do 1 over B, which that'll be Betty. And it says 80 minutes by herself. So 1 over 80. Because what that means is, hey, by herself in 1 minute, she has done 1/80th of the work. And in 1 minute together, they've done 1/16th of the work. It's about fractions. Hopefully that makes a little more sense in terms of talking about it as fractions, but that's where we're headed. But with that said, everybody, is this a solvable equation in your eyes right now? Is this solvable? Kinda, yes. So think about it like this. If there's one variable inside of the equation, always solvable. Always, always, always. Here's what we got to do. First things first, we have to get the variable by itself. Everyone, we have this big old fraction here, but we also have all of this that we can get rid of. Everyone, how would we get rid of a positive 1 over 80? If we're adding 1 over 80 to that left side, how do we get rid of it? If we see that we have a plus 1 over 80, how do we get rid of that 1 over 80? Exactly. We do the opposite operation. So instead of adding 1 over 80, we'll subtract 1 over 80 on both sides. This is the solution part. This is where things might, again, make more sense or less depending on your level of rigor here. So minus 1 over 80 on both sides. I'll just put this right over here. And so that's going to cancel out. Now, if we wanted to subtract these fractions over here, everybody, this is where knowing your fractions will really, really, really save you. My party people, what do we need if we want to subtract two fractions? What do we need? We need a common denominator. We need that, absolutely. We have to get the same denominator. So 16 and 80 obviously are not the same. But everybody, is there a number you can multiply 16 by to get to 80? Ooh, some of y'all knew that instantly. 5. Sounds good. Let's try that out. If I multiply 16 by 5 and 1 by 5, what I end up getting is, again, this canceled out. So we have 1 over a on the left side. 1 times 5 is 5. 16 times 5 is 80. Minus 1 over 80. Okay, cool. Now with that said, everybody, what's 5 minus 1? Right, that's going to be 4. So now we have 1 over a equals 4 over 80. So if anybody here, if we were able to make it to this step, you know, without passing away, right? We're looking at this. This is a proportion. If you wanted to, you could cross multiply and divide, but I can actually show you a much, much easier way to do this. We can actually go ahead and, well, the point here, everybody, isn't it to get a up top? Isn't that the point? To get a up here? To get a up top by itself, isn't that the point? Absolutely is. So everybody, here's what you can do. Remember this, whatever you do to one side, you must do to the other. So if I'm going to go ahead and flip this fraction to go from 1 over a to a over 1, I got to do the same thing on the right side. I will put the 4 on the bottom and the 80 up top. That'll be 80 over 4. Boom. And actually, isn't 80 divided by 4 very, very possible? What's 80 divided by 4? 20. That's it. A equals 20 minutes. And there we have it. And there we have it. Boom. And yeah, we could have absolutely cross-multiplied if you wanted to. You absolutely could have cross-multiplied. You would have gotten a times 4, so 4a. 1 times 80 equals 80. And you would have divided both sides by 4, and you still would have gotten a equals 20 minutes. Still would have worked just the same either way. But this is an example of honestly a peak word problem, because you got to know like this very, very, very niche idea, but once you know it, boom, there's your answer, 20 minutes. And everybody, doesn't that make a little bit of sense to you? Because if it takes Betty 80 minutes by herself and it takes Timothy 20 minutes by himself, given that Betty takes such a long time by herself, doesn't it make sense that, you know, working with Timothy, she's not going to help Timothy that much. She certainly will help, but it's not going to be a crazy amount. And so that might make a little bit of sense in terms of just the numbers adding up. But long story short, everybody, here we go. Combined work, there's your formula. A, B, and T are the times for person A, person B, and then the time for them working together. If you set it up that way and you solve, you'll be done. But very, very honestly, everybody, you may not see a question like this on the ASVAB unless you're on a streak. You know, if you get maybe 4, 5, 6 questions right in a row, this question might pop up. Definitely expecting those harder, higher level questions if you're getting more and more right as you're going through it. And I am not saying, I'm going to stop right there and say, I am not saying get questions wrong on purpose. Don't ever do that. Just know that if you get a question like this on the ASVAB, you should probably be proud because you have been getting a lot of questions right. Exactly, Landa. If you're looking for the total, you'll just add the fractions, and then at the end, the same thing. You got to flip them or cross multiply and divide because the t is on the bottom, and you just have to get it to the top. Yeah. Cool. So with that, my party people, let me go ahead and give you a chance to go and take a screenshot there. Are we feeling good or bad about this one here? How are we feeling? Again, be honest. I need you to be honest because this is definitely one where, hey, if you wanted to just go to Home Depot, buy some drywall, take your fist, punch it through the drywall, that would be socially acceptable for this problem. It's definitely one of those that if you're angry, it's all good. It's all good. But again, everybody, to write this down, this was going to be Unit 13, okay? Unit 13 in the arithmetic reasoning, if you want to practice this type of problem where you're working forward to find the total or backwards to find one of the people, that's where you'll find it. You'll also find mixture problems where they say, hey, this solution is 20% alcohol and it's going to be mixed with this solution that's 72% alcohol. What will the percent of alcohol in the combined solution be? So you'll have those problems, combined work problems, and then you'll have problems where you have two topics heavily mixed together like a system of equations with a perimeter problem, something like that. Yeah, so Joseph, if you log into the website, if you're in the program, you log into the website, and then you'll see the 3 math courses pop up. Your math basics, AR and MK. Go ahead and pick AR, and then go to Unit 13. Yep, super straightforward to get there. So let's see if this next problem is going to be a little easier for us, maybe a little harder. Let's practice the stamina that we're going to need to really employ on test day. So remember, everybody, this is one question. Let me ask you this for real. If you're taking the test and you saw a question like this and you tried your best on it and maybe you took like 5-6 minutes trying to do it, but then you gave up, how are you feeling going into the next question? Like, let's be honest. How might you feel going into the next question if you thought this one was impossible? Jaylene, great descriptive question, word there. Horrible, bad, sad, stressed. Right. So think about it like this, everybody. Do you control the questions that the test bank is going to feed you? Do you control that? No, you don't control that, man. You don't control that. Is it possible that you're going to run into a question that you don't know how to do on the ASVAB? Is it possible that you're going to run into a question that you don't know how to do? Right, of course. It's very, very possible. So remember this, everybody. Don't let the question that you're currently on affect your attitude going into the next one. The people that can take that hit and say, whoa, hey, I just didn't know how to do this one. I'm moving on to the next one. The people that look at it like that versus the people that, and I'm not saying you have a lot of control over this, but we can train for it. But the people that look at a question like this and their test anxiety starts raising their heart rate a little bit, they start getting in their own head saying, oh, crap, why did I come today? Oh, man, I knew I should have ate more before I came in. I'm hungry now. And you start getting distracted because you're just uncomfortable. We don't want that. Remember, one question at a time, one question at a time, one question at a time. Can't control everything. Let's go ahead and try this next one out, my party people. Go. So, everyone, no matter what, I don't care how hard you think a question is, the first step in every single word problem is read the question. Read that question, get a grip on what we're supposed to be doing here. So right here it says, hey, how old is Anderson? That's me. Okay. So I'm a little uncomfortable because I'm going to have to talk about myself in the third person. Well, here we go. So we're talking about this person named Anderson and we want to know how old he is. Sounds good. Blank years old. Sounds good. So we want to know how old Anderson is, and we can say that's blank years old. Okay, whatever. Now, let's go ahead and take a look at the information, and I'm going to show you how you can do this problem using the answer choices, and you can use this problem, or do this problem by setting up a system of equations. Either way will work just fine. So let's go ahead and get it through here. So, Delilah, guys, look. I told you guys time and time again, I'm 42 years old. If you don't believe me, I don't know what to tell you, man. I don't know what to tell you. So with that, here we go. How old is Anderson? Looking at the information, Anderson and Brandon's combined age is 40 years. Everybody, wouldn't that mean that if I wrote that down here, right here, Anderson and Brandon's combined age is 40 years, wouldn't that mean that we would say, Anderson plus Brandon. I'm going to just move this down a little bit. Equals 40 years. Isn't that what that means, everybody? Yes or no? In your opinion, isn't that what that means? Anderson and Brandon's combined age is 40 years. So that means that Anderson plus Brandon is 40 total. Right? Like, even if you don't know systems of equations, like, even if you don't know that, I hope that you can see that sentence when they say combined age. That means add up the ages, that's 40. Hopefully that's not too much of a stretch for anybody here right now. Now, the next thing is, hey, Anderson is 16 years older than Brandon. Let's turn that into math really quick here. Let's go with green right there. So Anderson, I'm going to type that out there. Okay, everybody, the word is, what does that typically mean in math? Yeah, that's an equal symbol. And then it says 16 years older than Brandon. So wouldn't that mean that Anderson equals Brandon plus 16 years? Isn't that what that means? Isn't that what that means? All right, great. So with that said, we have ourselves a system. That's what a system of equations is. A system of equations is literally two or more equations that use the same variables or same inputs. I was going to say inputs first, but basically two equations that have the same two variables. How do I know? Again, if I just shorthand this, A plus B equals 40. And then in green, A equals B plus 16. And there it is. But let me ask this question to the chat box here. Everybody, quick question. Are you comfortable with solving systems of equations? It's a yes or a no. Don't give me anything in the middle. Just give me a flat out yes or a flat out no. Are you comfortable with solving systems of equations? All right, so take a look at the chat box, guys. Like, this is literally, oh, it was half and half. Now it's a ton more no's than yeses. I was going to be excited if it was half and half, but the expectation was a lot more no's than yeses. This is a problem that you should definitely know how to do, for the simple reason being that actually you might not need a system of equations to solve this. You just need to be able to understand information. What do I mean? Here's one way to solve it, even if you didn't know how to solve it with a system. Basically, you have conditions. The ages add up to 40, and Anderson is 16 more than Brandon. What can I do with that information? I can use the answer choices. Here's what I can do. Let me start with answer choice A. Let's assume that Anderson is 12 years old. Again, it's so weird talking. Okay, whatever. But let's assume that I'm 12 years old. If I'm 16 years older than Brandon, is Brandon even alive yet? Is Brandon even alive? No. No, like, what dimension are we talking about? This ain't Doctor Strange Multiverse of Madness. Shut up. This is real life. That's not going to make sense. That's not going to make sense at all. Because if I'm 12 and I'm supposedly 16 years older than Brandon, if I subtract 16 from 12, that's -4. He can't be -4 years old. That's not going to make sense. No, we can't have that. Get that out of here. Get that out of here. Does everybody understand why A cannot be the answer? Because again, this is Anderson age. If Anderson was 12, that means Brandon is not alive at all. Next up, let's take a look at B, 27. Okay, guys, let's assume that I'm 27. If I'm 27 and Brandon's 16 years younger than me, how old is Brandon technically? How old is Brandon technically? If I'm 27 and I'm 16 years older than Brandon, how old should Brandon be? What's 27 minus 16? Yeah, it's going to be 11. That's going to be 11. And you can use the relationships that you have here. Anderson is Brandon plus 16. If Anderson is 27, what plus 16 is going to give you 27? 11. So if that's the case, again, if I'm 27, then Brandon is 11. But then it says, everybody, what do our ages together have to add up to? What do the ages together have to add up to? Oh yeah, 40, allegedly, right? Allegedly has to add up to 40. Okay, sounds good. If I add these together, what's 27 plus 11? Is that 40? No, that's 38. That is 38. Is 27 years old for Coach Anderson, is that the right answer? No. No, that's not going to work. Everybody, quick question. Are we seeing how using the answer choices can definitely help us here? If you know how the relationships are set up, and it's okay to say no, guys. Completely okay to say no. If you understand the relationships that they give you or the conditions that they give you, you can use that with the answer choices to make it make sense, to see if those answers make sense. But the best way to do it is obviously to know how to do a system, but you can still get away with setting it up like that. Let's look at the next one here. 28 years old. Okay, let's assume that I'm 28. If I'm 28 years old, everybody, and Brandon is 16 years younger than me, what's Brandon's age going to be? If I'm 28, right here, if Brandon is 16 years younger, Brandon would be 12. Everybody, is 28 plus 12, is that going to be 40? It is. So because that number satisfies the conditions of the problem, 28 plus 12 is 40, that's satisfied, and 28 is 16 more than 12, that's also satisfied because those two conditions are met. The two sentences that the problem tells you about, because those are both true with that number 28, because it's true, boom, you can safely, and I mean safely, assume that this is the correct answer, 28. That's one way to do it. That's one way to do it. We get the 12 by understanding the relationship here, Aaliyah. Anderson is 16 years older than Brandon. So if I'm 17 years old, take 16 away, Brandon's 1 year old. If I'm 28, take 16 away, Brandon's 12. It just depends on the number for the age that they use. And the answer is 28. If you use that guess and check method, I am not 28. This problem was developed 1 to 3 years ago. I'll let you guess at what that might be. But what we're going to do now is I'm going to show you how to actually solve the system right over here. I'm going to show you how to solve this. So the method that we're going to use here is called substitution. Long story short, here's how it works. You essentially have two equations, number 1 and number 2. They're using the same letters. Everybody, is it true? This A represents Anderson. This A also represents Anderson. Is that true? And no worries if we're confused. This is a system of equations. I'll tell you exactly what unit to go to in a moment. I got you. But here, both of these A's, they both represent Anderson. And again, this is going to be Unit 7 of Arithmetic Reasoning. Unit 7. This is definitely on the harder side as well, but this is systems of equations. Systems of equations. But essentially, right over here, take a look. These A's are the same. So what that means, everybody, think of it like this. If this A equals B plus 16, that means that this A equals B plus 16. And so what I can do is I can rewrite this equation here. I'm going to go and make this a proper arrow. So I can replace that with B plus 16. I can replace that A with B plus 16, and I can write everything else in the same exact way. That's what's called substitution. You can substitute the value of one equation, if it's the same variable, into the other equation, because both of the A's represent Anderson. That's how systems of equations works when it comes to substitution. If you're not quite there right now, don't worry. You need to learn how to solve equations first, very, very well, before you can get to this very confidently. So Unit 6 is where you want to start, and then Unit 7, that's this right here. But then again, B plus B, everybody, if I have a B plus a B, what do I get? B plus B is what? 2b. Yep, 2b. And so I have 2b, and then plus 16 equals 40. And so with that, everybody, we're going to subtract 16. I'm going to take over a little bit here. We're going to subtract 16 on both sides. That's going to cancel out right there. And we have 2b, zoom down just a little bit, 2b equals 24. And then from here, we'll divide both sides by 2. Right there, and we get b equals 12. Everybody, is 12 the answer? Is b equals 12 the answer? No, because b represents what? B represents what? Yeah, B represents Brandon's age. How do we get to Anderson's age? Right over here. Anderson is 16 years older than Brandon. If we plug that right in, we get Anderson equals 12 plus 16. Everyone, what's 12 plus 16? What's that going to be? What's that going to be? 28. And so A equals 28, and there's the correct answer. Boom. Both ways, we can still get it. Both ways. So to you, which way made more sense to you, or did neither way make more sense? The guess and check method with the answers, setting up and solving the system, or neither? Now I'm young. My body acts like it's 90 though. So with the second one, actually setting up and solving. Some of us like both. Some of us like guessing and checking. And again, it's going to be your preference. It's going to be your preference. It's all good. Who here? Yeah, absolutely. Take a picture. Feel free. Feel free. You know, this is going to be recorded, and we're going to be, you know, kind of taking these recordings and putting them, you know, on the courses. And we may release some of these to YouTube. But I'm actually going to be making a course for you, and it's already ready to go. I'm going to release it tomorrow afternoon. Basically, you're going to be able to retake this practice test, this entire thing. You'll also be able to look at the recording to watch this video solutions to every one of the problems. And you can take it timed to my website. Again, if you're in the program, look out for my email tomorrow around 1 o'clock. I'll be sending this out to you. Yep, absolutely, iPhone. Yep. So here we go. Are you guys ready to try one more problem out? And let me actually make sure. Okay. Yeah, are you guys ready to try one more out? If you couldn't tell, this one is a slightly harder practice test than what you're used to, but I think it's worth switching up the difficulty here and there. If you were here last week, some of them might have been a little more manageable. Today, a lot of them are a lot less manageable, but we have to perform under pressure, right? So here we go. 3, 2, and sorry about that. And 1. Go ahead and go. What are we looking for? Be specific and quick. Go. What are we looking for in this problem? Green crayons, right there. How many green crayons are in the container? Sounds good. Instantly, you need to, take attention right there. Green crayons, that's what I want. So, boom. I want blank number of green crayons, again, in the container. Okay, great. Immediately, I want to start looking at the information, and there are some key words that are going to give away exactly what type of problem this is. There are 3 types of crayons in the container: green, blue, and red. The container has a total of 144 crayons, and pay attention right here, ratio. And the ratio of green to blue to red crayons is 2 to 4 to 6. But right there, the word ratio tells you that this is going to be a proportion problem. They give you the ratio of green to blue to red, and now they're having you find the actual number of green. Comparing the same things in the same way is what we notice. This is absolutely going to be a proportion problem. So everybody, here's the thing. You always want to base your proportion off of the question. So you're looking for the number of green crayons. We got to see if there's another thing about the container that we know about. Everybody, what other piece of information do we know about the number of anything in the container? We're looking for the exact number of green crayons. Do we know the number of red or blue or something else that might be useful here? Landa, thank you. We have the total. We have the total. And because we have the total, bam, we can write that here. We're looking for blank green crayons, 144 total. I'm going to set my proportion up by comparing the same things in the same way. Immediately, you want to set it up by comparing green to total, and that's going to be the same thing on the right side. We're looking for, let's say, for G green crayons, and we have 144 total. So green and total. Now let's take a look at the other piece of information that they give us to show you how to set this up super quick. They tell you that the ratio of green to blue to red right over here is 2 to 4 to 6. So if that means if you read it in order, it goes green, red, or green, blue, red. So green corresponds to 2, blue corresponds to 4, red corresponds to 6. So what I know for myself right now, my party people, is that, hey, that green, that 2, that belongs right here. That represents green, so I'm good. But what am I going to put down here? Well, we have to represent the same things in the same way. The tops represent green, the denominators, the bottoms, represent total. And so we're going to add these right here. We're going to add them up. 2 plus 4 plus 6 is what? 12. Exactly. So we plug that in right there. And now we can solve. We can cross multiply and divide, or we can use our compare the same things in the same way method, which will actually give us a much easier time, because if you take a look here, I can go from 12 to 144 by multiplying by 12. And if I'm comparing the same things in the same way, if I'm going to go from right to left multiplying by 12, then I'm going to go from right to left multiplying by 12. 2 times 12 is what? 24. And that's where that comes from. And there we go. And this is a G. So excuse my horrible handwriting. That is a G, not a 6. That is a G. That is a G. But that's how we can get the answer rather quickly, or you can cross multiply and divide. That'll still work out just fine. But that's one way we can get the answer. And as always, my party people, thanks for watching. You can subscribe with that button right there, and you can also see a link to a video just like this one right up there. But most importantly, if you want the program and you want to raise your score the right way, every step of the way with my support, there's that link at the bottom left. Go ahead, click that link, watch the video on how the program works, subscribe, and raise your score.